Hello guys, my name is Balakrishna Srivastava and welcome to Code with BK. So in this video, we write Java code to understand the difference between pass by value and pass by reference. So before we begin, it is a request to please subscribe to my channel because out of 100 views, only 2 to 3 are subscribed. More than 95% of my audience is not subscribed, and your subscription is very important. So please do subscribe to my channel. And one more thing before we begin is that I teach coding in Hindi as well on a separate Code with BK Hindi channel. So my English channel Code with BK, I started it first back in 2018, and then through the years I started getting requests to teach coding in Hindi, for which I started this separate Code with BK Hindi channel. So if you people are comfortable with Hindi, it is a request that if you can maybe spare 5 minutes, check out this channel and let me know your thoughts and reviews about this channel. Okay. All right. So we have to understand what pass by value versus pass by reference is in Java. And I usually find some confusion in my students whenever I teach Java programming about this topic. And this video might be a little longer because I'm going to go deep with the concepts. And by the end of the video, there will be certain bottom lines, certain bullet points that I will conclude on. So it is a request to please see through the entire video to understand what the concepts are. Okay, so we have to understand what pass by value, okay, and pass by references. Okay, all right. So let's just first understand the type of values that we have in Java. So types, okay, often short for data types, are two types: primitive, and the second type is non-primitive values. Okay, primitive values are the one that can only hold values and they do not have any of their own properties or functions. So these include all our primitive types: int, boolean, double, float, char, short, long, byte, etc. Okay, any type that can only just hold a value, you cannot do any more operations on that, is called a primitive value. Non-primitive values are any objects of a class, user defined or predefined, okay, or arrays. These are non-primitive values because you can have functions and operations on them and they have their own properties. Okay, for example, if you take int k equal to 10, right, and you take int arr equal to 10, 20, 30, 40, 50. Okay, k is a primitive type. You cannot do k dot something. You are not allowed to do this because it just holds a value. The variable k is an integer type that is holding the value 10. Arr, you can do dot length to get the length. Okay, you can do dot all these functions. Okay, then you can say I want to get the first value, the value at the first index. You can do arr 0. You get the value at the second index at arr 1. So apart from just holding the values, you can also do operations on them. So they are non-primitive values. So pass by value is when you are passing primitive values to a function. Okay, when you're passing values to a function and those values are primitive, they are passed by value. In a moment, I'll just explain you what does this actually mean. And when you are passing objects of classes or arrays, okay, to functions, they are passed by a reference. Okay, object arrays passing to a function. All right, now what do I mean by pass by value? So let us just consider the memory that the program uses. Okay, and we have written this statement int k equal to 10. What happens behind the scenes is that this is your memory, right? For example, the mobile phones that you buy, you often consider the amount of memory that the phone provides: 128 GB to 256 GB, 512 GB, right? So GB is gigabytes. Okay, we have MB megabytes, we have KB kilobytes. So this is 10 to the power 3, 10 to the power 6, 10 to the power 9. Okay, the smallest individual unit of a memory is byte. So you can think of this when I say int k equal to 10 is integer requires 4 bytes. So a memory enough to hold an integer is holding the value 10, and the name of this memory is k, the variable k. Okay, when I say int k equal to 10, this is what happens behind the scenes. Okay, when I say int arr equal to 10, 20, 30, 40, 50, what happens behind the scenes is a chunk of memory, a contiguous chunk, one entire strip of memory capable of holding 5 integers is allotted, and arr will store address of first location. Okay, so this has values 10, 20, 30, 40, 50. Okay, ARR stores the address of the first location, and that's why when you do ARR of 0, this is equivalent to saying ARR plus 0, that is move 0 locations after ARR, that is stay at ARR, give me the first value, that's the value at index 0. When I say ARR of 1, it means ARR plus 1, it means give me the value at address of the first location plus 1, which is the second value, which is at index 1. Okay, similarly ARR 2, ARR 3, ARR 4. Okay, and that's why this process is constant time. Okay, there is no more further processing required to get me the first value or the second value or the third, fourth, or fifth value, because I can calculate the location where these values are stored using the address of the first location. Okay, so when I get a primitive value like this, it is just basically giving me memory enough to hold this variable, the value 10, and the variable is k. When I do this int AR equal to these many values, a contiguous chunk, one single strip of memory to hold these many integers is provided, and this is how it stores. ARR, the variable, that the array variable is the address of the first location. Okay, so when this value is passed to a function, it is passed by value. So if I write a code, a function to pass k, I say static void add 2 to k int k. I say k equal to k plus 2, and I say sys out. Okay, k in add 2, okay, is k. Right, let me just comment this for now. Okay, I am going to print k in main. Okay, then I am going to call this add 2 function, pass the value of k, and then I am going to print k in main after add 2. Okay, so k in main, the value of the k, then you're calling add 2 function, you're passing the value of k, some print happens here, and then when you return from the function, you say k in main after calling add 2. So when I run this, you see k in main is 10. Okay, add 2k, when you're passing 10 to this function, this k is equals to k plus 2, k becomes 12. You print k in add 2, which is now 12, and when you return from the function, okay, here you print k in main after add 2 is k, it is going to stay 10 because this is passed by value. It means changes made in this function are not reflected back here, so the value of k remains 10. What is happening behind the scenes is, how do you understand this? Is basically when you say void add 2 and you pass int k, you do k equal to k plus 2 and you SOPLN k. Okay, when you call this function passing the value of k, this k is a part of this main method. When you call this function, a function will get its own fresh copy of the value that was stored in k, because it is being passed by value. So the value in k is 10. So you get another variable, which is the name same k again, has the same value that was passed. Now this is k, and this is a part of add to function. Okay, so when you call this function, a copy of this value is passed into a fresh variable for this function. Then you say k equal to k plus 12, this becomes 12. You print k, so you get output as 12. Okay, when this function returns, whenever a function returns in Java, all the local variables are, or whatever memory was assigned in this, is collected by the garbage collector. So when the function returns, the variable local to this function were int k. So this is now collected, the value 12 is now collected. We lose this variable and we go back to the main where k is 10 itself. The value of k has not changed. Okay, that's why when you get back to the main, the value of k is 10 still. Okay, this is what we call pass by value, when you are actually creating a copy of the value and sending it to the function. Okay, if for a moment I change the variable name, add to int m, I do m equal to m plus 2 SOPLN m. In this case, what happens is you're again just passing the value. In this case, the variable is m. So instead of creating a variable k, a variable with the same value 10 that is being passed, okay, this is m now of add 2. Then you do m equal to m plus 2, this becomes 12. Okay, so if I do int m, this is m equal to m plus 2, and I have to print m, and I'll say m in add 2. I run this, m is 12, but k in main is 10 only, because when this function returns, all local variables are collected by the garbage collector. This is collected by the garbage collector, and k remains 10. This is passed by value. And all primitive values, int, boolean, double, float, char, short, long, byte are all passed by value. A separate copy of the value is created when you're passing the variable to a function. So primitive values are passed by value. Okay, non-primitive values are passed by reference. Now what do I mean by this is, I take this memory again. Okay, I go back to what I have in my main, k and arr. Okay, I'll just comment this out for now. Okay, I just have arr. So what I told you, that arr, okay, is the number of locations that you have provided, 40 and 50, and arr, the array variable, is the address of the first location. Okay, if I write the same function, okay, but I pass int, say a in this case. Okay, I say for int I equal to 0, I less than a dot length I plus plus, and I say a of I equal to a of I plus 2. I'm incrementing all the values in this array by 2, and then I can say a in add 2. Okay, so let me just write a function, static string. Okay, so a in add 2 is going to be arr to string, and you pass pass a. Okay, so first I'm simply going to print arr in main, okay, in this function, and I pass arr. So I'm going to simply get the string form of this 10, 20, 30, 40, 50, 10, 20, 30, 40, 50. If I add 2 more values, it becomes 60, 70. Okay, 60, 70. All right, taking 5 values again. Okay, I call this add to function now. So this is arr. So when I run this code, this is going to print arr to string a, which is now all these values incremented by 2. So 12, 22, 32, 42, 52. So 12, 22, 32, 42, 52. When I print this array again in my main, okay, this is going to have the changed values now, 12, 22, 32, 42, 52, because this is being passed by reference, and changes made in the function are reflected back in the original function. Okay, why this is happening? Because you have something like this. Okay, arr variable storing the address of the first location. That's why you can access arr0, arr1, and so on. When you call this function void add 2 and you pass int, okay, when you call this function passing arr, this add to function gets is its own a, okay, and this is in add 2. Okay, we are passing the reference, that is we are passing the address of the first location. We pass the same address of the first location, so arr was pointing to this array, so a is also pointing to this array. Okay, and you when increment every value by 2, okay, you iterate this entire array, you increment every value by 2. So this is now 12, 22, 32, 42, and 52 instead of 10, 20, 30, 40, 50 respectively. Okay, and then when you print, okay, you're printing by passing a. A contains 12, 22, 32, 40, 52. That's how you get the second output. When the function returns, all local variables are lost, so this is lost. Okay, but there is still a variable in main accessing this, so this memory is not collected. Garbage collector will only collect a memory if there is a memory which is no more accessible by any variable. This variable in the main can still access this array, so this is not collected. So when you go back to the main, this variable arr is pointing to that array to which changes were made, okay, because we passed the reference. So now when you print again, you get the changed array. Okay, this is what is called pass by reference, because we are passing the reference, the address where this value is stored, so the changes made are reflected back in the calling function. Okay, so I'm going to tell you a few more things that are going to be critical. So if I have this function now, int add 2, taking the value int k, incrementing k by 2, k plus 2, and return k. Okay, so in this case I am returning the value k, int and alright. So in this case, since I'm returning the value, the changes are going to be reflected. Return m, sorry, since I've changed m. Okay, alright, so making this, okay, for some reason this deleted everything. I'm just gonna draw this again. Okay, in this case what happens is we have, I'm gonna comment this out. Okay, Copy this, paste this, uncomment this. I'll say k is now return value of add2, and then I'm going to print this statement k in main after add2. Now the changes are reflected back in the calling function because we are storing the return value. Now k is 12 after add2. Okay, because when I say k equal to 10, this is my k in main. Okay, when I call this function, I'm passing the value of k, which is 10. This add2 will get the same value. This variable m is a variable of add2. You're doing m equal to m plus 2. This becomes 12, and then you're returning m. So this value is returned and stored in the k of main. Okay, add2 returns 12. So now this becomes 12. So now that you print, you get 12. Okay, so if you want changes made to the primitive value to reflect back, you should be returning. Okay, all right, let's just work with an example of objects, because let me just do this again. Okay, we had primitive, we saw what are primitive values, non-primitive values, and we saw the example of arrays when you're passing an array. All right, and we saw if you want to change, save the changes made in the function, we need to return the value in case of pass by value. This is what we just saw. Okay, now let's just pass an object and see how this works. So if I have a class car, so this class car has a name, make, model, 3 data members. It has a constructor that sets the values, initial values, and we have a toString to represent this object as a string so that we see the name, make, and the model values. Okay, in my main, okay, I'm going to create a car object C1 equal to new car, and let's say name is Polo because I have a Polo right now. Okay, make is Volkswagen, and model is 2014. Okay, I'm going to simply say C1, which is my car in main, is C1, and since I have this toString function, it will return me a string. So when I run this, I get Polo Volkswagen 2014, the values that I'm passing, name, make, and model. Okay, now I write another function. I say static void update model, and I pass a car C, and I say C.model now becomes GT, and I'm going to say in this function C in update model is printing this C now. Okay, so this will be printing Polo Volkswagen, but the model has changed to GT, so it prints, I need to call this function update model, and I pass C1. Okay, it prints Polo Volkswagen GT, and then when I print this C1 in main after update model, it will reflect the changes made. That is the model now from 2014 that was changed to GT will be reflected here. So you get, okay, C in main after update model. What happens behind the scenes is this is also passed by reference. Okay, what happens behind the scenes is if I have, this is my memory, right? Okay, I create a car object, so car object will get its own memory, and since we have given it values Polo, Volkswagen, and 2014, these are the values for my object C1, which is in my main function. Okay, I created a function void update model, okay, and I pass car C in it. Okay, when I call this function passing this C1, this reference is passed, that is this variable C is also pointing to the same object, which is a variable in update model function. Okay, then I say C dot model is now GT, which is what I'm doing here. So since objects are being passed by reference, C is pointing to the same object, that is C1 is pointing to, I change the model to GT, so now model from 2004 becomes GT. Okay, and then I print, so I get Polo Volkswagen GT, which is my second output, Polo Volkswagen GT. When I return from the function after printing, okay, all local variables are lost. Okay, so this variable is lost, but this memory is not collected because this is still accessible by C1 in main, and garbage collector will only collect memory if it is no more accessible by any variable. So when you get back to main, this C1 is pointing to this object, which is Polo Volkswagen GT. So the changes made are reflected, and that's why when you print C1 in main after call to update model, you get Polo Volkswagen GT. And this is another example of pass by reference. Okay. All right. What if I create a new object? If I say static void change car, okay, that I setting C to another object altogether. I say C equal to new car. Now name is city, make is Honda, type model is type R. I'm not sure if we ever have type R in India. And then I print C in update model. Okay, I create the car, I call change car now. Okay, all right. So I will get Polo Volkswagen 2014, the first line of output. Then I change the car, I created a new object, so I get city Honda type R. And when I do C1 in main after update model, I get my original Polo car only. So I get my original Polo car. This is because you created a whole new object using a new keyword. And what happened behind the scenes was, we take the same idea. We have Polo Volkswagen 2014, okay, which is C1 in main. Okay, you create another function void change car. Okay, you pass a C reference. So when this function is called, the variable C is going to point to the same object because it is passed by reference. All right, then I say is equal to new something, a car. We are using the new keyword, so we get a whole new object that is pointed by C now. So I get a new object with values city, Honda, type R. Okay, so C, rather than pointing to this, is now pointing to this. Okay, and then we print, so we get C in the function change car is city, Honda, type R. And then when the function returns, okay, after printing C, when function returns, all local variables are lost. So this is the local variable lost. This was the memory that was accessed by this variable. So this is also collected by garbage collector. Okay, this memory remains there because it is still pointed by C1. So when the function returns, C1 is pointing to the original object, which is Polo Volkswagen 2014, and that's why in this case the original object remains the same. Okay, so the bottom line is, if you want to make changes, you can, they will be reflected back. But if you create a new object altogether, the changes will not be reflected back. In order to reflect back changes when you are creating a new object, what you will have to do is, you have again this. Okay, so using new to create new object, and changes are not reflected back. Using new to create new object. Okay, horrible handwriting, apologies. This is passed by reference, making changes in update model and changes reflected back in the calling function. In this case, again, we take the same thing, Polo Volkswagen 2014. This is object C, all right, in my main. All right, I do, in this case, the return type is car. I say change car, and I pass car C. I'll say change car one, different function name. I create a new car, C equal to new, say Honda, and I return C in this case. What happens in this case, when you call this function, this is creating, this is C1, this is creating a new variable C, which is pointing to the same car in change car one function. Okay, when you do this, you are creating a new object. Okay, let's take the same city, Honda, type R. Okay, now C, rather than pointing to this, is pointing to this. All right, then you return C. When you return C, this object is returned to the calling function, this object. And if I have, say, static car change car 1 and return C, and in my function I do, instead of change car, I do C1 equal to change car C1, change car 1 C1. It means the object that I am returning from this function is now stored into C1. So now C1 points here, and this memory is collected by garbage collector. So now C1 is city, Honda, type R. So in this case, C1 is city, Honda, type R. Okay, because you created a new object and you returned that object. So this this object that was pointing originally to this is now pointing to the return value from this function. Okay, bottom line is, if you are creating a new object, you have to return it if you want the changes to reflect. Otherwise, if you do new and then you make changes, it won't be reflected back. Okay, if you just want to make changes, don't use the new keyword. All right, so next thing is, you will now argue that strings are passed by value. No, they are passed by reference. It's just that strings are immutable. Okay, strings are also passed by reference only. Okay, so because classes and objects are passed by reference, and strings and arrays, sorry, okay, objects of classes. So string is a class. Okay, so any object of string, any string variable is going to be an object of string that is passed by reference. It's just that when you think you are changing a string, you are not actually changing a string, you are reinitializing the string. Strings are immutable. What I mean to say is, if I comment this out, okay, I take string s equal to hello, system.out.print s in main is my s, so I simply get hello. Okay, then I do char ch is exclamation. Okay, and then I do s plus equal to ch, and then I do this. Okay, so this is appended to the string and then s is printed. Okay, so what has happening in this case is, again, think of in terms of memory. When you have a word hello, okay, in your string s, which is in main, okay, this is your this line, then you print, so you get this as the output. Then you do char ch, same primitive value, so you get a location to hold an exclamation, and this variable is ch in main function. Then you do this, so s plus equal to ch expand to s equal to s plus ch. So you create a new string s plus ch. So you create a new string s plus ch, which is hello, with this exclamation appended, and then you set this string to this s. So now this s pointing to this is lost, and now this s is pointing to this hello. Okay, so you are creating a new string and setting it to this variable s. You are not actually changing the contents of the string, because strings are immutable. Strings, okay, strings are immutable. You cannot change the individual contents of the string. Okay, so that's why you think in this case that you are changing the string, but you are actually not. You are just reinitializing the string to a new value. Any string function, that's why, returns a new string. For example, if you think of s dot replace, so replace, you see, returns a string resulting from the replace or occurrences. Then you see say maybe 2 lowercase, returns the string, okay, converted to lowercase. So all these functions will return a new string. There is not a single function that will change the individual contents of the string, right? That's why if you pass a string, say static void add ch, and say string s char ch, and you say s plus equal to ch, okay, you say s in add ch, you print this. Okay, so if I simply take s string is s equal to hello, print this, okay, and then comment this out, okay, then I say s in main after add ch, okay, I call add ch string and pass this question mark. Okay, the string remains the same in my main function. String remains the same, okay, because behind the scenes what is happening is, you have this function, okay, void add ch s and ch. Okay, in your memory you have a hello, okay, that is s is pointing to in your main. Okay, then you have call this function, okay, add ch. When you call this function, you get two variables for this function. So you have s pointing to this in your add ch, okay, and then you get another variable ch that is holding the question mark. This is your in add ch function. When you do this, s plus equal to ch, s plus equal to ch behind the scenes this is happening. So you do s equal to s plus ch. So this is creating a new string s plus ch. So a new string s plus ch, hello, with this ch is created, set to s. So s, which was pointing to this, is now pointing to this new string, which is then printed in the next line. Okay, and then when you return from this function, after printing, when you return from this function, all local variables are lost. So this is lost and this is also lost. And this is also lost because s was the only variable assessing this. Since we are returning from the function, this variable is lost. So this memory is also collected by garbage collect. Okay, so when you return to the main, your s is hello itself. Okay, that's why s is hello itself in your main after calling add ch. Okay, so this is how basically pass by value and pass by reference work. Okay, so summing this up, when you're passing a primitive value, it is pass by value. If you want your function to reflect changes made in the primitive value, you have to return the value. Okay, if this is simply void, you are making changes to it, changes are not reflected back in the calling function, you have to return this updated value and store it in the original variable, like here, to reflect changes. Okay, whenever you are passing an array, okay, it is passed by reference, so changes made are reflected. If you set this to another array, say arr equal to new something, then these changes will not be reflected because you are using the new keyword, just as in the case of these objects. Okay, you used a new keyword. Okay, so this is entirely a new object now. A reference to the old object is with the original variable only now. Okay, so whatever you do here, okay, if you're not returning the value, the changes will not reflect it back. Okay, if you have to use the new keyword, you should return the new object that you have created from this new keyword. Okay, if you don't have to use the new keyword, you can make changes, they will be reflected back because this reference will be pointing to the original reference. Okay, all right, one last thing I'm gonna tell you is something you might not agree, but I'm gonna tell this. So whatever I have told you is something that you should keep in mind whenever you are giving your interviews or giving an exam. Okay, this last point is basically for computer science engineers who are looking for knowledge, is everything is passed by value only. There is nothing like pass by reference. Nothing is passed by reference. Okay, and when I say this, I mean is pass by reference is actually passing the value of address of an object, which we call pass by reference. So whenever you are passing an array, okay, or an object, you're actually passing the copy of the address where that object or an array is stored. In this case, we are passing C1, where the C1 is stored is copied in C. Again, address where C1 is stored is copied in C. Similarly, address where the array is stored is also copied in the variable that is passed. Okay, so pass by reference is nothing but pass by value, and the value is the address of the reference, address of the object or value of the reference. Okay, and this is just knowledge, and because at one point you will understand that even in C++, when you are sending pointers, right, passing pointers is also passed by value only, because pointer is an address of a location. Okay, you're copying the address of a location. Now how do you think about this is, for example, if you know where your friend lives, if I tell another guy where my friend lives, so that guy also knows where my friend lives. Okay, so if I can reach my friend, okay, that other guy there whom I told the address can also reach my friend. Okay, so this was it, and I hope this was clear. I hope I did not go way too much deep into this. Okay, also apologies that this sometimes happens, this glitches, and I lose my notes that I've written so far, but that should be okay, I guess. Okay, so this was the concept, and I hope this was helpful. So if there is any doubt, there is a part you don't understand, please let me know in the comments. I always try to answer all comments. You can also let me know in the comments if there's a question you want to solve or the concept you want to discuss. So please like this video, subscribe to my channel, and thank you for watching.